everyone, I'm Hoang. I would like to present the joint work with Châu Nghĩa Nguyen and Minh Ngọc Trân on the dynamic leverage stochastic volatility models. The leverage effect of financial returns is the phenomenon that negative returns tend to increase the volatility process that have been analyzed by the Seminars paper Black in 1976. One explanation for this leverage effect is that negative shock to the returns may increase the financial leverage ratio between debt and equity. Therefore, stocks become riskier and which result in higher volatility. However, a major study considers a constant leverage over time, which is a rather restrictive assumption. And time-varying leverage have been addressed in several studies, like Bandis, Yu, and Bretus, among the others. In this study, we propose the dynamic leverage stochastic volatility models based on the constant leverage stochastic volatility models, and we allow for the correlations between the returns innovation and the volatility innovation to follow a generalized autoregressive score process. We find that both the sign and the signals of the temporal returns innovation are the main factors that increase the leverage effect. We estimate these models. We use annealing sequential Monte Carlo algorithm of Chen and Yuan for posterior approximation. Annealing sequential Monte Carlos is an efficient samplers for Bayesian inference that combines the annealing importance samplings and the sequential Monte Carlo method. The dynamic leverage stochastic volatility models involve both in-sample fit and also out-sample forecast comparison to the fixed leverage stochastic volatility models. We illustrate the proposed dynamic leverage stochastic volatility models using three daily stock return index, the Dow Jones, the FTSE, and the Nikkei since 1990. These figures show that the filter volatilities and the filter's dynamic leverage effects. We can see that the pattern of the filter volatility are very similar among the series, even though the leverage effect of the Nikkei is weakest and is more volatile at the end of the samples. On the other hand, the dynamic leverage effects of the Dow Jones is quite stable through times, while that of the FTSE is decreasing. Next, we analyze the impulse response function of the temporal returns innovation, epsilon and epsilon t minus 1, on the correlation or the leverage effects. Here we show the contour plot of the correlation on the effects of the Dow Jones temporal return innovation. So according to the sign and the magnitude of the epsilon, we will see that the leverage effect is reinforced when observing both strong temporal negative return shock, and it's also the leverage is weakened where we have both positive return shock. And we also see an interesting scenario when we have a market uncertainty gain when the epsilon t minus 1 is greater than 0, but the epsilon t minus 1, epsilon t is less than 0. So the leverage effect is weakened also. And in uncertainty market loss, we will see that the leverage effect also increase. So thank you for the listening, and here is the reference.